All right, so after spending some good amount of time learning and getting fluent with the square root and how to operate with square root, so now in this video here, allow me to introduce one special property that we so-call the square root property. Okay, and so the fundamental idea of the square root property is now introduced on the computer screen right here. All right, so the square root property is stating as following. If x squared equals k, and for k being a value that's greater than or equal to 0, then x can be equal to either the positive square root of k or the x equals negative square root of k. So from this statement, we can understand that if x squared from the beginning is equal to a non-negative value k, then the value for x itself can be equal to two separate values. X can equal to square root of k, or x can equal to negative square root of k. There are two separate possibilities that x can equal to. I will get back to at the end of the video lesson to explain where that result came from, where that square root property came from, and how it was derived. But allow me to move on to show a direct application, a direct impact, a direct usefulness of that square root property. So allow me to show that in the following example, which is also regarded as a demonstration problem. All right, so in this example 1 right here, where I also use this example here as a demonstration problem to demonstrate the straightforward application and the direct usefulness of the square root property. So in this problem right here, in this example, we are asked to solve the following equation. So what we have here is the equation. So we want to solve that equation for x. So the idea of this equation here is that, so we have an unknown. So the x in our problem that we're trying to solve for is the unknown. It has an unknown value. So we want to find out what will be the value for that unknown, so that the square of the unknown must equal 169. And that's the whole point of solving the given equation for x. Okay? And so now to get into solving this equation right here, the unknown we have being x right here, but now the form that we're looking at right now is directly the unknown square. So the impact from the direct impact from the square root property that we have seen earlier is that now we think about, hey, if we have an unknown expression being squared, or another way of saying it, if we're looking at the square of some unknown expression to equal a given value being a non-negative value, then we can do the following. So x squared equals 169. I can just simply apply the square root property to say that, hey, on one hand, the value for x, the unknown, and this time I don't need to write the square anymore. On one hand, the value for x, the unknown, is equal to the positive square root of 169. And another possible solution, and that's why I'm logically speaking, it's the or. So on one hand, x equals square root of 169, or on the other hand, x may also equals negative square root of 169. And so we come up with these two possibilities of the value for the unknown x, which came straight out from the square root property. And so now advancing a little further right here, I'm looking at, on one hand, x may equal the square root of the positive square root of 169 is giving me 13. So x may equals 13, or x equals negative 13. And so once again, let me clarify the keyword or here. What it's saying or here, the statement saying or here, simply indicating that any one of these two answers, any one of these two values for the unknown x will answer this equality from the beginning, that the unknown square being equal to 169. So if x equals to 13, x squared will equal to 169, positive 169. Or if x equals negative 13, then x squared will also equal to 169. And that's why it's the or keyword right here. But in the end, generally speaking, the most direct usefulness, the most direct application of the square root property is that we can apply that into a lot of times solving for some equations where we recognize that our equation here having the unknown involved as a square. So the square of an unknown equals a non-negative value. All right, so let me now bring you into another demonstration problem here where I so-call that the example number 2 right here. And so after this problem right here, we should be able to see even deeper and further the impact, further application of the square root property that we've learned. So in here, once again, we're asked to solve the following equation for x. And so once again, similar to the earlier problem that I brought up in example 1 right here. So solving an equation here means we're just basically, we were looking for the value of the unknown. So here in our equation, we have the unknown being x. And we want to find out which value of x that reach equality between the left-hand side and the right-hand side. Okay? But so in our equation here, what we're seeing here, we are falling right into that setup that we have a perfect square. And so a little bit unlike the problem I have done in example 1 right here, what we have here is some expression that's a little more fancy, a little fancier than the earlier problem. The earlier problem was just simply an x squared. And here I have an x minus 3 all squared. So some expression squared equals to, and on the opposite side here we have a number being a non-negative value right here. Okay, so in the end, no matter how fancy it looks right here, what I recognize here is as a majority, as a major understanding right here, that we're having a square, a perfect square. So the emphasis of the square root property is it's not only always just an x squared, but it can be just basically an expression being square. And that's the situation being here, and we can apply directly the understanding from the square root property. So here I'm looking at an expression being square, or more precisely, the square of an expression. The square of an expression equals a non-negative value. And so now the square root property is stating as following, and this is how we can apply the square root property. So the way how I'm seeing it, the expression now, x minus 3, without the square, the expression without the square, on one hand equals to the square root of 16. Or we can obtain the value of the expression x minus 3 as the negative square root of 16. So the way how it says now is that the expression x minus 3 squared equals 16 if x minus 3 itself without the square equals positive square root of 16, or x minus 3 without the square equals the negative square root of 16. So any one of these two possible values here will lead to x minus 3 all square equals 16. But so now in this way right here, I realize that I have produced for myself two separate little equations. So the one I wrote on my left-hand side right here reduces down to x minus 3 equals the square root of 16 is simply 4. So now I have x minus 3 equals 4, the unknown minus 3 equals 4. And so now to obtain the value for the unknown, right from this equation, I can just simply add 3 from both sides. And this is now a skill that we have learned from our past courses that we've learned right there. Adding 3 to both sides, I'm looking at the 3 here cancel out, and 3 plus 4 equals 7. So x, the unknown, equals 7. But for the other equation, or if x minus 3 equals negative square root of 16, negative square root of 16 is a negative 4. So we have done and should be fluent with square root at this point. So negative square root of a number is indicating that I have to take the square root of the number, then put the negative sign there. So now this equation here really produces x minus 3 equals negative 4. And that once again I have arrived at some simple equation where we are asked to solve for the actual unknown x right here. So bringing in some understanding from our previous course, I'm going to add 3 to both sides. And now canceling out the 3 on the left-hand side, making it x. And now we are equal to x equal to minus 4 plus 3 gives me negative 1. So what it says now is that if x equals 7 or x equals negative 1, any one of these two values for the unknowns will lead to x minus 3 being squared equal 16. And that's how we have solved for this equation here. And the method we use here is the square root property. All right, allow me to bring in the third demonstration problem right here, where I call that example 3 right here. And once again, we're asked to solve this given equation here for the unknown value that we name a. All right, and so once again, I'm seeing that on one side of our equation here, we have an expression, generally speaking. Now we should see that as some expression being square, some expression with the unknown being square. And then that equals a value. Unfortunately, for this equation right here, the value on the right-hand side violates our requirements right here. The requirements for the number on the opposite side of the unknown square gotta be a non-negative value. So the value on the opposite side here needs to be non-negative. And by saying opposite side, I mean the side that's opposite from the unknown, from the expression with the unknown with the square. Okay, and so the squaring side, the squared side is here, and the opposite side is here. But unfortunately, in our case right here, the opposite side fails to be a non-negative value. It is a negative value. So that's something we observed. Negative 4 is negative. And this is why it fails the requirement. So now in this case right here, my straightforward answer, and my only answer that makes it possible, no solution. And so I brought in this example. Sadly, it had no solution, meaning we cannot find a value for the unknown here satisfying this equality. And that's what no solution means. But I brought this in simply to emphasize that in order to really apply the square root property, it is strictly required that the number on the opposite side, the value on the opposite side, and again, by saying the opposite side, I mean the side that's opposite from the squared expression. That side right there must be a non-negative value, 0 or higher. All right, so at this point in our lesson, allow me to really get into the explanation of about where this square root property came from and how it was derived here. And so, forgive me for writing that here on the board to be slightly different with how it was worded originally on the computer screen that you were seeing. But in the end, the major elements are all still here. Under the strict requirements that the number k, the given value k on the side that's opposite with the square expression, under that requirements that the k has to be a non-negative value greater than or equal to 0. If we have an expression square equals k, then x, the expression itself without the square, equals on one hand the square root of k, the square root of the value on the opposite side, or x equals the minus square root of k. So let me now explain where that comes from. So let's start with x squared equals k. So if we know this, then mathematically speaking, we can take the square root both sides. If x squared equals k, then as far as the property of an equality, we can equally take the square root both sides. Square root is an operation, so we can apply that operation on both sides. So now in my next step right here, the square root of k on the right hand side remains the square root of k. But now from our learning from the lessons about square roots, taking the square root of a square expression truthfully gives me absolute value of x right here. And this came from the property that we've learned in the previous lesson, that square root of an unknown of an expression square equals absolute value of x. But then we further learn that if x is a non-negative value, then the absolute value of x will equal simply just x, where there's no further absolute value notation required here. But on the other hand, if x is a negative value, so I'm talking about if the actual value for the unknown right here is a non-negative, then we can just, the absolute value will always equal to the number itself. Or if the value for the unknown is a negative, then taking the absolute value of the unknown, it means it's going to be negative of x, means the opposite value of x, because the whole purpose of absolute value is always to purposely get a positive value. So if the unknown is already positive itself, then taking the absolute value is no difference with just the value itself. There's no need to put the negative sign. But if the value of the unknown is a negative value, then taking the absolute value of x, we purposely force that to become positive. But in reality, forcing a negative value to become positive, it means we put a negative sign in front. Okay, so the negative or the opposite of the negative value, this will make it positive. Or for short, we have arrived from earlier courses the following result. Absolute value of x on one hand equals to x if x itself is greater than or equal to 0. This is how I wrote that statement in a more organized way. Or absolute value of x will equals minus x if x is a negative value. So now what led into all of these, starting to get a little complicated logical arguments here, simply because the x variable here is an unknown. And being unknown, it could be positive, it could be 0, or it could be negative. So we have to come up with a generality that handles all situations. But so now allow me to utilize this understanding and bring it back into the other work that we're currently in. And so now at this point right here, once again, from the x squared equals k, I have explained how we arrived at absolute value of x must equal square root of k. So that means in the next step, on one hand, absolute value of x can equals x if the unknown is a positive value. And that's why we can have directly square root of equals square root of k on the right hand side. This is for the case where x itself, the unknown, may be a positive value. But then on the other hand, this absolute value of x will break into minus absolute value of x in case that the unknown may be a negative value. And so in that way, equating that with, we can equate that with square root of k. But this little equation here, this little equality here means further that, x equals negative square root of k. And for this equation, it's going to, of course, stay the same. And so we have come to that final generality, which states that if the square of some unknown expression equals k, then the unknown expression on one hand can equal to square root of k, or on the other hand, the unknown expression can equal to the minus square root of k. And that's how the square root property came around.